Welcome to our lecture series for Engineering Mechanics Statics. My name is Rafael Nico Castañeda. I'm a civil engineer by profession and a college instructor teaching engineering subjects to undergraduate courses. These are the recommended textbooks that we can use in this lecture series. For our first video in this lecture series, we will discuss the following topics: Introduction, Newtonian Mechanics, Mass, Force, and Weight. For the introduction, we will define some important terms related to the study of statics. These are engineering, mechanics, physics, and engineering mechanics. For engineering, it is defined as the application of mathematical and physical sciences to the design and analysis of things for the benefit of mankind. Mechanics, on the other hand, is the branch of physics that considers the action of forces on bodies or fluids that are at rest or in motion. Physics is defined as the science that relates the properties of matter and energy, including thermodynamics, electricity, magnetism, and nuclear physics. From the definition of engineering and mechanics, engineering mechanics is the branch of engineering that applies the principles of mechanics to mechanical design, that must take account the effect of forces. Let us now discuss the different branches of engineering mechanics. The diagram shows the different branches and sub-branches of engineering mechanics. Statics, which is the main focus of our lecture series, is also part of the diagram. Let us start first with the three main branches of engineering mechanics. The first one is mechanics of fluids. It deals with the study of liquids and gases that are at rest or in motion. A fluid is defined as a substance that continually deforms or flows under an applied shear stress, regardless of the magnitude of the applied stress. The next one is mechanics of deformable bodies. It deals with the internal force and deformation developed from actual engineering structures and components. A deformable body is defined as any body that changes its shape and volume, while being acted upon by any kind of external force. The last branch of engineering mechanics is the mechanics of rigid bodies. It deals with the external effects of rigid bodies, which is classified into statics and dynamics. A rigid body is a solid body in which deformation is zero, or so small that it can be neglected. The distance between any two given points on a rigid body remains constant in time regardless of external forces exerted on it. Under mechanics of rigid bodies is statics and dynamics. For statics, it deals with the distribution and effect of forces on bodies which are at rest and remain at rest. Dynamics, on the other hand, deals with the study of motion of bodies and their correlation with the forces causing them, which is classified into kinematics and kinetics. Under dynamics, kinematics is the study of motion of bodies without considering the forces causing the motion. Kinetics, on the other hand, is the study of motion of bodies together with the forces causing the motion. Our next topic is Newtonian mechanics. As a review in our physics class, let us start with Newton's laws of particle motion. The first law of motion states that if a particle is at rest, or moving with constant velocity in a straight line, it will remain at rest, or continue to move with constant velocity in a straight line, unless acted upon by a force. The second law states that a particle acted upon by a force will accelerate in the direction of the force. The magnitude of the acceleration is proportional to the magnitude of the force and inversely proportional to the mass of the particle. The third law of motion states that for every action, there is an equal and opposite reaction, that is, the forces of interaction between two particles are equal in magnitude, and oppositely directed along the same line of action. In our upcoming lecture videos in statics, we will discuss how these concepts can be applied in some topics in engineering mechanics. The next topic under Newtonian mechanics is the Newton's law of universal gravitation. According to this law, if two particles of mass ma and m be separated at a distance r, which is measured center to center of the two masses, the law states that the two particles are attracted to each other by forces of magnitude F, that act along the line connecting the particles. An illustration of this law is shown in this figure. The magnitude of the force is represented with the formula, F equals g multiplied to the product of the two masses divided by the square of its center to center distance. where g is the universal gravitational constant, equal to 3.44 times raised to -8, feet to the 4 over pound second to the 4, or 6.67 times 10 raised to -11, meter to the cube over kilogram second squared. Let us have an example problem for universal law of gravitation. For this problem, find the gravitational force exerted by the Earth, on a 70 kilogram man whose elevation above the surface of the Earth, equals the radius of the Earth. The mass and radius of the Earth are 5.9742 times 10 raised to the power of 24 kilograms and 6,378 kilometers, respectively. To understand the problem, let us have an illustration. According to the problem, the 70 kilogram man is located at an elevation above the surface of the Earth, which is also equals to the radius of the Earth. To calculate the gravitational force, we need to determine the center-to-center distance measured from the center of the Earth to the man. In this case, the center-to-center distance is equal to twice the radius of the Earth. Before calculating the magnitude of the gravitational force, let us first present the given values. The mass of the two particles, the man and the Earth, is shown. The center-to-center distance between the two masses, denoted as r, which is illustrated previously, is also calculated and expressed in meters. Using the formula of the gravitational force, let us use the SI units value of g, to have consistency in the units. Take note that the resulting unit from the solution will be in newtons. The final answer for this problem is 171.4 newtons. Another important concept in studying engineering mechanics is to define and know the difference between mass, force, and weight. The definitions and formulas relating these three functions are presented. Mass, a measure of quantity of matter contained in a body, referred to as a measure of resistance to change in velocity, which is known as inertia of a body. Force, is the product of mass of a particle to its acceleration vector. As stated in Newton's second law of motion, the force vector is equal to the mass multiplied by the acceleration vector. Weight, is the force of gravitation acting on a body, using g as the gravitational acceleration. On Earth, the gravitational acceleration g, is equal to 9.81 meter per second squared or 32.2 feet per second squared. The weight of a body with mass m is determined using the formula, W equals m multiplied by g. The table shows the common units used for mass, force, and weight. For mass, the most common unit is kilogram and gram for SI units, and slug for US customary. For both force and weight, the most common units are Newton and kilonewton for SI units. Pounds and kips for US customary is also used. Let us have an example problem. A person weighs 30 pounds on the moon, where the gravitational acceleration is 5.32 feet per second squared. Determine, a, the mass of the person in slugs, b, the mass of the person in kilograms, c, the weight of the person on Earth in pounds, d, the weight of the person on Earth in newtons. The given values in the problem is presented as shown. For problem A, we can calculate the mass of the person by dividing its weight on the moon, to the gravitational acceleration of the moon. Take note that the mass of any particle is always constant. Calculating, we get the answer of 5.64 slugs. For problem B, to get the mass of the person in kilograms, we just need to convert the answer in problem A from slugs to kilograms. The resulting answer will be 82.3 kilograms. For problem C, we can calculate the weight of the person in Earth in pounds, by using a gravitational acceleration of 32.2 feet per second squared. Take note that 1 pound unit is derived from 1 slug accelerated by 32.2 feet per second squared. Using the formula of weight equals mass times gravitational acceleration, we will get 181.61 pounds. For the final question at D, we will calculate the weight of the person in newtons by using the mass in kilogram and gravitational acceleration of 9.81 meter per second squared. Using the formula, weight equals mass times gravitational acceleration, the weight of the person on Earth is 807.36 newtons. Thank you for listening. I hope you learned something from this lecture video. Don't forget to answer other problems for practice, to improve your analytical skills and critical thinking. Remember that this video is only for guidance in your studies, your effort is what will help you learn more. Don't forget to like this video and subscribe to my channel. See you on our next lecture video.